Hey, it's Chapter 2. Welcome back. In this chapter, we're going to use what we learned about trigonometry in the first chapter to find missing sides and angles of right triangles. Okay, so we're just going to go ahead and talk a little bit about what it was that we did in Chapter 1. For instance, if I give you theta as 45 degrees, you immediately drew it in standard position as I have on the screen. And once the angle was in standard position, from the end of the ray we would draw from that terminal point, we would draw perpendicularly back to the x-axis and have a right triangle here, and then we could find, for instance, the cosine, the sine, and the tangent of this 45-degree angle by using our special right triangles, right? So this is x, these are the same side, and this is x root 2. All right, so in Chapter 2, we leave this idea of the cosine, sine, and tangent being x over r, y over r, and y over x, because for some strange reason in Chapter 2 they're drawing the right triangles just any old place. Okay, so let me show you what I'm talking about. Let's say this is triangle ABC, and I give you the sides of the right triangle, and I ask you to find, for instance, the cosine of A. And you remember that that means x over r, but that's only if the angle's in standard position. If I look at this triangle the way it is, which one is x, 3 or 4? Right? So when the triangle is not drawn in standard position, it's impossible to find the x and the y. The r is not bad. The r, we realize, is just the hypotenuse of the right triangle, but the x and the y just depend on the orientation. So because of this reason, we are allowing you to go back to what you learned in geometry, and that is that the way we find the trig ratios is to use SOHCAHTOA. All right, but you have to promise me that you will not forget the x, the y, and the r. All right, because we're going to get back to that. So anyway, SOHCAHTOA tells us that to find the sine of any angle A, so for instance this angle A here, we would take the opposite over the hypotenuse. Right? And so in this case, opposite A would be 3 and the hypotenuse is 5. To find the cosine of A, now we take the adjacent side over the hypotenuse, and that would be 4 over 5, and then the tangent is the opposite over the adjacent, and that's equal to 3 over 4. All right, so when we have a triangle not in standard position, we need an alternate way to find the trig values, and that's how we do it. Okay, moving on. In this section, we talk about the sine and the cosine are considered co-functions. So you agree that the sine of an angle, the sine function and the cosine function are functions. They are co-functions, and here's the reason why. Let me go ahead and set up a right triangle and call these angles A and B. And I hope it's pretty easy for you to understand that A and B, when added together, make 90 degrees. All right? We have a fancy name for that. They are complements. You remember that. And so the deal is that with the sine and cosine is that the sine of A, let me write that, sine of A is the same as the cosine of B. All right, if we go back to that 3, 4, 5 triangle, let's go back and look at that one. So opposite the A was 3, and adjacent to the A was 4, and the hypotenuse was 5. And so the sine of A is 3 over 5. So when we're at A, opposite is 3, and hypotenuse is 5. When we flip to the other triangle, the other angle B, now I'm talking about the adjacent and the hypotenuse, and sure enough they are equal. All right, so that means that if I tell you the sine of 53, you would say, I know that the cosine of 27 will have the same exact value. Next section we're going to use our calculators to find it. Okay, hopefully that's pretty clear. Well, let's go back now for the ending of this video and go back to our special right triangles, because in this chapter we're going to have things, quizzes that are called exact value quizzes. So we put EV for exact value quizzes, and they are based on the 6 trig functions for special right triangles. Right? So in the beginning, we draw the right triangles and we come up with these trig functions, and then at some point you're going to have to memorize them. So let's go ahead and we'll go ahead and look at the 30, 60, 90. And again, you notice not in standard position. And so even though we don't know any of the sides of this triangle, we can find the cosine, the sine, and the tangent. Let's start with 30 by simply setting up the sides and the relationship. So we know that the opposite the 30 is x, the hypotenuse is 2x, and opposite the 60 would be x root 3. All right, so the cosine of 30, I'm going to do adjacent over hypotenuse, and those x's cancel out, and so root 3 over 2 is the cosine of every 30-degree angle. And this is important to recognize, that it doesn't matter how big the sides of the triangles are, that if one of the angles is 30, then the ratio of the adjacent to the hypotenuse will always reduce to root 3 over 2. Using that same reasoning, the sine is going to be the opposite over the hypotenuse, and that reduces to 1/2. And then the tangent, if we take x over x root 3, we get 1 over root 3. Okay, so because 30 and 60 add up to 90, we can find the cosine of a 60 by simply looking at the sine of a 30. Do you see that? These guys are co-functions. Likewise, the sine of a 30 is going to be, I said 1/2 and I wrote 1/3. Sorry about that. The sine of a 30 is going to be the exact as the boy, and I'm changing the numbers. Let's say that over again. The sine of a 60 is going to be the same as the cosine of a 30, root 3 over 2. The tangent, we can't use a cofunction here to find it. So let's go ahead and, using that tangent is opposite over adjacent, look at the 60 here and put x root 3 over x, and it turns out to be root 3. Okay, so these are the measures that you will eventually memorize and take a quiz on. Okay, so the last special triangle, and then I'm going to finish here, is the 45, 45, 90. So this is 45, 45, and 90. So we know the relationships are there, and so the cosine of a 45 turns out to be x over x root 2, which becomes 1 over root 2. And then we've got the sine of a 45, which turns out to be the same because they are cofunctions. And then the tangent of a 45, well, the opposite and the adjacent are exactly the same measure, and so those are 1. Okay? So in class, you don't have to worry about this exact value quiz right now, but in class we're going to practice these values over and over again, because in trigonometry, when you see a 45-degree angle, you need to think this relationship right away. It's kind of like those multiplication facts that you had to memorize, but in trigonometry. Okay, a lot of information. See you in class on Monday, and we'll practice this a lot.